Question number 19 says, find the sum of the products. So the products of the corresponding terms of the sequences 2, 4, 8, 16, 32 and 128, 32, 8, 2, 1 by 2. Corresponding products, that's what we are interested in, yes. So 2, 4, 8, 16, 32, that's the sequence. It contains 5 terms. This is geometric progression. Then you have 128, 32, 8, 2, 1 by 2. This is also a geometric progression. Can you see that? Yes. Common ratio is 1 by 4. The common ratio here is 2. R1 is 2. R2 is 1 by 4. And if you multiply the corresponding terms, what do you get? You get 256. You get 128. Then you get 64. Then you get 32 and you get 16. And this is also a geometric progression R having common ratio 1 by 2. Which is simply the product of these two. Don't you think so? Yes. That's what we have, right? So finding the sum is possible if you directly add these few terms, or you can use ideas of geometric progression to find this sum of first 5 terms, where the first term is 256, common ratio is 1 by 2. So sum S5 will be first term 1 minus common ratio raised to power number of terms upon 1 minus common ratio. This is 1 by 2. It goes up, this becomes a 5, 1, 2, and you have 1 minus 1 upon 2 power 5. What is that? This is 2 power 9, this is 32, it's 2 power 5, right? This here is 2 power 5, which is actually 32. So this becomes 2 power 9 into 31 upon 2 power 5. Now 2 power 5, 2 power 9 will be 16, 2 power 4 is 16. 16 times 31 is what we are interested in. Now 16 times 1 is 6. And 16 times 3 is 48 plus 1 will be, 16 times 1 is 6 plus 1 carry. 16 times 3 is 48, 48 plus 1 is 49. 4, 9, 6 is what we seem to get, right? This looks like the final answer. Let's check the calculation once. Right, we can directly find the sum as well, okay? And if we directly find the sum, what do we get? This is 80, this here is 160, right? So this becomes 240. 240 and 256 is 4, 25 and 24. 25, 24, 24 is 48, 496 is what you get, right? 496, right? So that's the complete sum of this. So what do we identify? The important thing to identify over here is if you multiply corresponding terms of two GPs, the resulting sequence is also a geometric progression and the common ratio is the product of R1 and R2 over here, right? That's what we have done, and this is how we can solve this 19th question.